we created in our previous lesson. And in this one, let's start by pressing R for the rectangle tool. Hover over this front corner endpoint, and notice that if you're hovering over the endpoint and you subtly move your mouse, so you're still over the endpoint, but you're sort of moving it around, you'll have this blue, red, green inferences. They're trying to figure out what direction to draw this rectangle in. Don't worry too much about that. Just click on the endpoint no matter what inference you're getting to begin drawing your rectangle. Then move your mouse, and notice if you move along the right face here, you'll get a red inference. It'll say on face, that's a blue dot, but you'll see the red lines trying to draw a face that is perpendicular to the red direction. If you move across the other side, you'll get a green inference, and if you move across the top, you'll get a blue inference. In our case, we're going to go across the top. So go ahead and go anywhere across the top and click where you have an on-face inference to finish drawing a rectangle on top. Now, if you push down on your center mouse wheel button to turn into the orbit tool and orbit above, I just want to point this out, orbit over the top, roll your mouse wheel back to zoom away. If you orbit just right, you can see this is essentially just one large rectangle with another smaller rectangle drawn on top of it. So this is like something we could have done in 2D, but I'll orbit back to where we're at. So the same principles will apply in 3D. Now we'll learn a new tool. Let's press P for push-pull. Push-pull is over here on your large tool set. It's the box with an arrow going up. So let's hover over the new surface. Remember, these are subdivided surfaces, so we have two surfaces up top. But hover over this new surface, click on it, and let go of your mouse. Then move your mouse up or down to push, pull, or extrude this up or down. So extrude it up a bit and click to stop your push-pull. And you'll notice that's an easy way to get some really cool new shapes going. Now try this. Go back to the same surface, click, and begin push-pulling down, so you start carving this away. Now move your cursor all the way down until you get this on-face blue dot, or you'll also see, if I move it back up and then move it down again, you'll also see that you have this sort of partially white, partially blue face. Go ahead and click, and you'll notice that it carves completely away, so it disappears. So what happens is when you push-pull this top surface down to a parallel surface, which is the bottom surface, they cancel each other out, which is a handy way to carve something away, as we did here, or as you'll see later, to punch out openings, like say for a door or a window or some other hole that you have in an object. Now the push-pull works on any flat surface. So we have flat surfaces everywhere here. You can click and push-pull the top up or down. And try it on the others, and I want you to push-pull all the faces until you get something that is an L-shaped kind of structure like what I have on my screen. So try using push-pull on each of the surfaces. Remember, the way to use the mouse in SketchUp, click, let go of the mouse button, move the mouse, click and let go to stop. So don't click and drag. That's the wrong way to do it. Even if it produces what looks like the same result, you want to always click and let go, move the mouse, and then click and let go. Now when you have the L shape I have here, let's move on to a few things that we can do with the push-pull. First, I want to set up a new shape to work with, so press C for the circle tool. And let's draw a circle on this inside right face. Notice before we start drawing that if you move your cursor onto the top face, you get a blue inference. On the right face over here, you get a red inference. And on this inside right face, you get a green inference. Now before we start drawing, let's say we want this circle to be perfectly centered within this bigger rectangle. So to do that, we're going to need to use our inferences. Go ahead and hover over the top edge. Don't worry which direction your circle flips. Mine is flipping blue right now. That's okay. We're not clicking yet. We're just hovering across the top edge. So move your cursor along till you find that blue midpoint. Don't click there. Just hover over it. Then find the midpoint of this right vertical edge. So hover along it till it snaps to a midpoint. And then move your mouse away and try to find the point where you get a dotted line shooting from the right and from the top. At that point, go ahead and click, and then move your mouse. So you started drawing your circle, that was the center point, and then move your mouse, and we don't want it to be bigger than the rectangle. So move your mouse some amount where it's inside, and go ahead and click. to finish drawing that circle. And you know now that it's perfectly centered. Now let's talk about push-pulling this circle. So press P for push-pull, and go ahead and hover over that new surface and click on it to begin push-pulling it out. Push-pull it out a certain amount, and then click to end your push-pull. So it works on flat surfaces, but not curved ones. So notice if you put your cursor over the curved surface, you get a little no symbol on it, this cylindrical surface here, and if you click on it, it'll actually yell at you and say, cannot push-pull curved or smooth surfaces. So you can only push-pull flat ones here. Let's push-pull this flat one again. Click to push-pull it, and let's say that we want to push-pull it so that it's the exact same distance away as the outside face is over here. Well, if you try to eyeball things, especially in perspective here, you're going to get it wrong. So let's try to infer something like the distance of that outside face. So move your cursor. While you're in the middle of a push-pull, you can move off of it. Notice that it doesn't matter if you're on it, which means you can move your cursor onto this face, anywhere on this outside face, and go ahead and click to finish your push-pull. And what you just told SketchUp to do is to take that face and push-pull it the same distance out that this face was. To check and see, just orbit around, and you'll see that, yep, it is push-pulled out even there. Let's try to push-pull this back halfway. So with the push-pull tool, click on that surface and start push-pulling it back. Now again, we never want to eyeball this, so we know we need to infer something. So move your cursor over to this top edge. Now as you're hovering over this edge, I'm not getting any on-edge inferences, but that's okay. With the push-pull tool, just keep moving along that edge, and then eventually you'll hit a point where it'll snap and say midpoint. Go ahead and click there, and you finished a push-pull that is now exactly halfway, or in line with that midpoint. Okay, now let's say that we want to push-pull this all the way back so that it's flat again on the surface it came from. So with the push-pull tool, click once, let go of your mouse, and then begin moving your mouse so you're push-pulling it back. And again, we don't want to eyeball things here. So even if you think you've got it real close, you're guaranteed to be some tiny, tiny fraction off if you try to eyeball it here. So instead, what's something we can infer? Well, how about just the face that we're going to? So move your cursor on the face that you're trying to infer, and go ahead and click on it. Now you know that you've finished a push-pull where this is perfectly flat back on the surface that it came from. So we can push-pull this cylindrical surface out. We can push-pull it back flat. What about push-pulling it through so that we create ourselves a tunnel? Let's try that. Go ahead and click on the surface and begin push-pulling it through. You can see that you start to get a little bit of a tunnel going. But as soon as your cursor hits something, SketchUp might start to try to infer, like for example this edge. Don't worry, if SketchUp tries to infer things along the way that confuse it, just keep moving your cursor confidently back through. Now at this point you have no idea where, you can't see what you're doing. But if you keep going, you'll eventually notice that the push-pull is going not only through as a tunnel, but it's actually going even further. That's not good either. We just want to create a tunnel through this, not something that extrudes out beyond. So how do we get a tunnel that ends on the other side? Well, you can move your cursor over to this outside corner endpoint to infer it and click on it. That finishes your push-pull through to the other side. And as we know, this flat surface, when push-pulled to the other flat surface, if you go ahead and orbit now, it canceled it out. So now you can see through, or if you orbit around to the other side, you can see that the push-pull happened all the way through and created a tunnel with this cylindrical surface inside. Orbit back around to the view you had, and go up to your undo arrow and click it once to undo back to where you had that surface back on this side. I want to show you another way to do the same push-pull, but maybe with a little more confidence than what we did last time. So with the push-pull tool, click once on the face and let go of your mouse. Now move your mouse around and you're in the middle of a live push-pull. Now press down on your center mouse wheel button to turn it into the orbit tool and orbit around until you can see the back. As soon as you let go of that center mouse wheel and you move your mouse around, you'll notice that you're still in the middle of a live push-pull, which now allows you, if you orbit till you can see the back, and you're in the middle of a live push-pull now, it allows you to put your cursor on this back face and click to finish your push-pull and actually see the result as it happens. So the first way was perfectly fine, where we just inferred this top point, and in some ways it was quicker, but you'll find that as you do more complex things in SketchUp, sometimes it's really good to see exactly what you're doing, and being able to use the mouse in this way, where you start an operation like the push-pull, and then you use your mouse to orbit around and then complete the operation. That's only available because we use the navigation tools in the mouse. We use that 3-button scroll wheel mouse, and we use the mouse the right way, where we click, let go, move the mouse, and then click and let go to finish. So if anything about this example didn't work for you, just undo back and remember all the steps. Do them all in the correct order. So that's to click and let go of the mouse button, then press down on the center mouse wheel to orbit, then let go of that center mouse wheel. You're still in the middle of live push-pull. Then move your cursor onto the back face and click and let go to complete that push-pull. Okay, if all of that's working for you, great. Let's talk about a couple more things that this will bring up. First, maybe I want to have a tunnel over here. Maybe that's something that looks great. But maybe I want to have it closed up over on this side. Okay, so one thing you could do is orbit around to the back. And in order to close this, to put a lid on it, so to speak, remember that in 2D, this would just be one big rectangle with a circle in the middle of it, and the circle just is missing a face right now. So forget about everything else that's going on in 3D. Your two-dimensional principles apply here. We need to heal this surface back in, and we can heal a surface by tracing on any of the edges. So what do I mean by that? Press L for the line tool, and you'll want to make sure that you're not zoomed too far out. So if your vantage point is real far away, you're going to have trouble with this. Roll your mouse wheel forward toward the edge of the circle, the edge being the full circle edge. And remember, circles are made up of 24 different segments. So with your line tool, I want you to find an endpoint, click on it, and then trace to the next endpoint and click on it. And you trace from endpoint to endpoint, which caused SketchUp to say, got it, you need to heal that surface back in. Roll your mouse wheel backward, orbit around, and you'll notice that this side is open and you have a tunnel going here. And if you come around the back side, this side is closed off, just as we wanted. Now let's say that you want this closed off and you also don't want to see this ugly looking edge. It should look flat over here. There should be a tunnel over here. Well, one thing you might try is press E for the eraser tool and go ahead and click anywhere on the circle edge and you'll erase it. Everything looks great, no problem. But if you orbit around the other side, hold down on that center mouse wheel and orbit, you still have the hole over here, but notice that you're missing, if you orbit around, you're missing that interior tunnel. So that cylinder was made up of this circle edge and the other circle edge. So when you got rid of the other circle edge, that surface, that interior cylindrical surface, had to go away. So how do we fix that? How do we get what we want on the other side without losing the tunnel on the inside? We'll orbit back around to the view you had on this side and undo back a step before you deleted that circle's edge. In SketchUp, when you need the geometry to exist, so this circle, it needs to be there, but you don't want to see it, instead of erasing, you have the option for hide. Now in the bottom left-hand corner of your screen, if you have the eraser tool selected as I have, you'll notice in the bottom left corner of your screen, and this is true of any tool, there will be words that will tell you some things about the tool you have in hand. And there will also be some keyboard shortcuts that will give you extra functionality. So notice here that it says some things about the eraser tool, and then it says that Shift equals hide. So if you hold down the Shift key on your keyboard, go ahead and hold down that Shift key on your keyboard, then move your cursor onto the edge of the circle and click on it the same way you would if you were erasing it, and then let go of your Shift key. At first it looks like you've erased it, but actually I know you've hidden it, and if you orbit to the side view, you can almost see a little bit of a ghost kind of an image here. Don't worry, that won't show up if you need to actually export some sort of rendering later or some sort of presentation image, that won't show up. It's just a little relic that you can see here. But if you orbit around the other side, you'll see that the tunnel has stayed in place there. But if you orbit onto this side, you can't see the circle there. So that's just an odd little thing for this abstract example, but it's just important to note you erase away the geometry you don't need, and when you need it but don't want to see it, you can actually hide it. Now, if you've hidden geometry and you need to get it back again so that you can manipulate it or you want to see it again, of course, we could just undo, but let's talk about how to find the hidden stuff if it wasn't necessarily the last thing you did. Go up to your Edit menu and select Unhide, and then Last would do it because that was the last thing we hid, or All because it was everything that we've hidden. So I'll go ahead and pick Last in this case, and that will unhide that circle. Now there's one more quick tool I want to cover in this example. So press down on your center mouse wheel to turn into the Orbit tool, and remember small incremental orbits around. Roll my mouse wheel backward to zoom out. And on this face over here on the left, I want to center a rectangle. So we centered a circle here. I want to center a rectangle on this face. So we won't be using the rectangle tool to do this because it's hard to use the rectangle tool in inferences to do something like what I want to do. So there's a new tool that we'll use called the offset tool. Press F on your keyboard for the offset tool. It's this tool here that has an arrow coming from an arc and then a red arc. And here's how the offset tool works. Hover your cursor on the surface, not on an edge, but on a surface. Now that surface will actively highlight blue, and you'll notice that this little red box is following along, for me, the top edge here while I move my cursor. If you move your cursor towards the bottom edge, it'll be there. Over towards the right edge, it'll be there. And it's basically trying to decide where you want to offset from. So for this example, hover over the face where your cursor is closer to the top edge, not on it, but closer to it. And then this is a two-click tool. Click once, then move your mouse, and you'll notice that you're offsetting 4 edges from the 4 edges of the actively highlighted surface. So all the edges of that actively highlighted surface are being offset now. And then move your mouse down to offset them in a certain amount and click. Now, because of perspective, it might seem like this offset was greater than this one over here, but if you orbit around, you'll notice that that was actually a perfect offset on all sides. So that's going to be a handy thing for things like windows or in plan view, walls, and many other things. But for right now in this abstract shape, we just wanted to center a rectangle. And now because we've been using push-pull a lot in this example, let's switch back to the push-pull tool, press P for push-pull. And now I see that my active highlight is not really actively highlighting as I move around. It's sort of stuck here. So right-click in white space to deselect anything. And now as I move my cursor around the model, I'm getting that active highlighting. Hover over that new surface there in the middle, click and push-pull it back a bit, and click to let go. So you can begin playing around with this new surface that you created. And just because you offset these perfectly doesn't mean you can't click and push-pull that. That might be a mistake. You might not want to do that, but it's also a possibility. Any surface is fair game. I'll hit escape so I leave that alone. So go ahead and play around here for a little bit, push-pulling different surfaces, maybe creating other offsets, and get comfortable with the push-pull tool before you move on to the next lesson.